Okay, so we got a question right here. In 1908, Rutherford, Wigger, and Marsden investigated the interaction of alpha particles with matter. In one set of experiments, they directed alpha particles towards a thin golden foil. State why the alpha source and gold foil were contained in a vacuum. So, let me explain it through basically a diagram. So, for example, this is our chamber, right? This is our chamber, right? Our detector is here. This is our detector, our chamber, and this is our source, which is alpha particles. It releases alpha particles, right? This is our source for alpha particles, and it goes through the cold foil, right? This is our cold foil, right? Okay, so why we make this chamber basically vacuum, like for example it doesn't contain any kind of molecule, it's like empty, like free space, right? So because the first reason is that if there is air molecules inside a chamber, like for example there are, like for example, the air molecule consists of oxygen, carbon, and many other atoms, right? So if they're basically having these atoms in here, then the alpha particle might get deflected or might not reach this detector at all, because in the air molecules, like oxygen has charge, right? Carbon has charge also as well, right? So basically these charges might deflect each other, like we know that positive and positive repel each other, or positive negative attract each other, so basically that's why we make this chamber like vacuum, like it doesn't contain any kind of molecule except the alpha particle source, the gold foil, and the detector, right? So we can write it as, so no, basically wait, so no collisions basically, because there are so there is no collision basically, so there is no collisions with air molecules, or you can write it as, you can give the example of detector, right? So that the air molecules doesn't stop, doesn't stop alpha particles from reaching the detector, right? These are your final answers, right?